Hello everyone, I'm Yvonne, a children's librarian here at the Manchester City Library, and welcome to Elementary Experiments. Here we do experiments and activities aimed at elementary grades 1 through 6 with a focus on STEAM, or science, technology, engineering, art, or math. This fall we are changing up our dates. So we are going to have in-person events at 3:30 p.m. on the second Wednesday and the fourth Tuesday of the month. We will be putting up our videos at the same time as our in-person experiments, which again is a little different than how we normally do it during the school year. But if you want to join us in person next time, please visit our website to register. Remember, in-person attendance will also guarantee you a kit to make our craft with. Although any extra crafts will be available at the Children's Reference Desk for anyone's grade 1 through 6 who wants to make them at home, possibly following along with our videos. Now that we've got all of that covered, let's get into this week's elementary experiments. Hello everyone, and welcome to this elementary experiments where we are talking about earthquakes and a couple of the ways that we learn about earthquakes and how to prepare for them. So we are going to go ahead and make a shake table on which we can test earthquake buildings or plans, and then we are going to build our own version of a seismograph, which is how scientists keep track of earthquakes, or a way that scientists can record earthquakes and how they hit and their strength. So to make our shake table, or something that we can use to sort of see how an earthquake would affect something that we put on top of the table, we are going to need a couple of pieces of pretty sturdy cardboard, because they're going to take some tension on them. So you want them to be strong pieces. Then we are going to need a couple of rubber bands, and then something to make the table roll. So I actually have 4 different little bouncy balls, and these are nice because they're solid, so they're not going to collapse underneath the stress of our shake table. I've also used some like very strong paper towel rolls before, like not the normal kind, but like there are some that are like super thick cardboard. Those can work as well. Also, I have heard people use tennis balls to make the shake tables. So really, just whatever you have, you can sort of test and see if it will work, but don't use anything that you would be upset if it got squished, because it might get squished. So we have these quite large and strong rubber bands that we are going to put over, oops, we need that later, over both pieces of cardboard, just flat on the edge, and then on this edge here. So we've got maybe about 4 inches of space in between. And these cardboard pieces are about the size of a regular piece of paper, right? So about 8.5 by 11. Okay, now what we're gonna do is we're gonna take the bouncy ball and we are going to go ahead and open up this and kind of shove it inside. And we're going to do that for each one at the different edges. Here we go. Okay, so this can be a bit tricky because we need to get them all in there without the other ones rolling in like weird ways or rolling out before the tension is distributed evenly. So if that does happen, don't worry about it. You can just try again. Or if you are having a lot of trouble, go ahead and try and find a partner to help you like hold a couple of the balls in place while you insert the last. Okay, so we have the basics of our shake table right here. How you make the shake table shake is you go ahead and you hold down the bottom piece, right? So you put your hand in between and hold that down, and then you would pull the top piece of the cardboard in one of the directions. And a good way of making sure that you know how far you have pulled the cardboard is to take a ruler and lay it in the direction that you are pulling the cardboard. That way, when you look straight down at the ruler, you will be able to see that you have pulled it like 1 inch or 2 inches or etc. All right, I'm going to try and show you this. So basically you grab it, you pull it, and then you let go. Oops. Make sure your hands are out of the way. And there, see how it shakes back and forth? All right, and that's basically the earthquake motion, right? If you want to get fancy, you can try and make it shake it a little bit around, especially if you have balls that will roll under it. If you have the paper tubes, then it will only shake in like one direction. I did just lose one, hold on. During that demo, I did have one escape out of the edge. Again, that will happen. We can just stick it right back in. Okay, so we have our basic shake table. Now a fun thing to do with this is if everyone has like a manila folder or like a thin piece of cardboard like you would get out of a off the side of a cereal box, you can actually go ahead and build yourself a building. The way we're going to do it is we are going to take some of these toothpicks and marshmallows and basically use these as kind of like a Richter set or like Lincoln logs, really anything that you would build by sticking things together. And what you would then do is keep building your structure until it would be 6 inches, or at least that is our suggested challenge, but you can do what you want and build your structure. Right, so I have created this little house. It is not 6 inches, so it is smaller than our suggested one, but I just want to show you guys real fast. So basically I put this onto my manila folder. If you are doing this as a group or you have more than one person, especially if you're going to make it a challenge to see who can build the most stable structure, I would say that you should probably decide on the rules for attaching it to your manila folder or your cardboard. Because we don't have foundations on this building, which is the things that would attach it to the ground or go under the ground, they are going to be more slidey. So I would go ahead and decide on how you are allowed to attach it if you want to be able to attach it. So if you're allowed to use glue or tape, or be able to like stick things into the manila folder, I would decide that ahead of time. But what we're going to do then is grab our shake table. We will then put our creation on top of our shake table, and we're going to use up to 4 binder clips. Those are these little or alligator clips. So you squeeze them and they open, and we're going to clip them onto our base. And this is basically to protect our shake structure And then also, again, to anchor your building if you decided that anchoring is a thing. All right, so what we're going to do for our test is we have our shake table with the manila folder, our thin cardboard secured to protect the shake table and possibly to secure or to act as your foundations if you have secured your building. Then we have our ruler, on this case my tape measure, that I put right up to the edge, and then I can use that to go ahead and pull this back. So if I'm going to pull this back 1 inch and then let go, there you go. You can see how my building, it moved, but it did not collapse or fly off. Again, my building is very short. It's just so you guys can kind of see the basics of how it goes. But my building did move across the ground. So if I was going to build a tiny house in an area with an earthquake, I might be concerned that the building would just move. And so I would think that maybe it needs stronger foundations. Maybe it needs to be have like pylons that go down. So maybe I would attach this to my foundation. Basically, if your building doesn't function perfectly, or even if it totally falls apart, that's okay. That's all part of the learning process. And just think about how you could build your building so that it would last longer during an earthquake. And if your building is actually fine, you can always go ahead and pull the shake table even farther. So if you started out at 1 inch, go ahead and try and pull it to 2 inches. And then let go and see how strong of an earthquake your building can actually withstand. All right, so that is our activity. I hope it sounds pretty cool and that you will try it yourself. Hello everyone, welcome to our craft for our earthquake elementary experiments. So for today, we are going to build a seismograph. So scientists who study earthquakes in a hope to understand them and better predict them can use a seismograph as a tool to record earthquakes and measure their strength. So this is basically the most basic form of a seismograph that we are going to make, because obviously we can make it with the things that we have at the library, but this is what scientists did use before we had all of our fancy electronics and whatnot. So in our craft bag that you can pick up from the Manchester City Library if you are in grades 1 through 6, while supplies last, we have, of course, our instructions. Then we have a small paper cup. We have 5 different cardboard sides, and we have 2 pieces of string. Now from home, you are going to need some small heavy objects. I have dice, which are not the heaviest, but they are what I had around me. You're going to need some tape. You're going to need a marker, preferably a felt-tipped one. That's one with like a magic marker that has kind of like the cloth tip at the end, not a ballpoint pen. We're going to need some paper that is blank on at least one side, some scissors, and then a pencil, which I'm going to use to poke some holes. So, where are we at? All right, so first off, we are going to have to build the box of our seismograph. So we're going to look at our cardboard, and you're going to notice that 2 pieces are a lot smaller. These are going to be our top and our bottom. One of the pieces are going to have 2 holes punched in it. That is going to be the top. Of the 3 remaining pieces, 2 of them are going to have little notches carved out of the bottoms, and those are going to be the sides, and the notches on the bottoms are going to be actually at the bottom. So what we're gonna do is we are going to go ahead and match up the sides to where they are. We're gonna rest these on top like so. So we have this little notch at the bottom. And then we are going to tape our box together so that that notch is not covered by our tape, okay? So we've got most of our box put together, and our final piece is the one with the 2 holes. It's going to go on top. Obviously, as you saw me do, you can put this box together by yourself, but it is so much easier to do if you have a partner with a second set of hands to kind of help hold up the walls while you tape them. But we are almost done. Also, the box itself doesn't have to be the most beautiful. It just has to hold together while it takes its recordings, and it doesn't shake apart when we shake it to simulate an earthquake. So here we have our box with an open side. So now we are going to take our cup, and we're going to go ahead and punch some holes into the side of the cup. Okay, then we are going to take the string that was in our kit, and we're going to thread it through the hole that we just punched in our cup, maybe with the help of our pencil. And we are going to tie the string to the cup, 1 string on each side. Okay, now what we're going to do is we are going to thread the other ends of the string, and we're going to thread them up through the holes in the roof here, the top, so that the cup will hang inside of our box. All right, what I'm going to do to help me get the hole through the holes in the top is I'm going to add a little bit of tape to the ends of my string, just like you have at the end of a shoelace. All right, and then we are going to try and tie this off so that it hangs evenly. I did tie mine in a bow, so I could retie it if I needed to. Okay. Our next step is to take our marker and make a hole in the bottom of our cup that is big enough to stick that marker through. Okay, and we want our marker to like just be touching the floor of our box, okay? So that's pretty good. And this is where my marker is actually doing pretty well, but this is where we add our small heavy objects into our cup to keep it hanging straight down and to kind of help our marker not fall over. Okay, so the last thing we need to do is to take our paper, and we're going to fold it in half. And then we're going to fold it in half again. And then we are going to cut down all of these lines and then tape them together with the tape on the back side. So I have one side that's printed. I'm going to make sure the tape is on the back side so it doesn't interfere with our seismograph's drawing. All right, so again, it is good to have a partner to do this because we are going to feed our paper through the little slots. All right, and it's good to do this on a flat surface. Mine is actually a bit tilted. Ugh. But basically what we want to do is we want the marker to just be touching on the paper. So what we do next is we're going to have one person ideally pull on this paper here very steadily. So we would get a line being drawn by our marker, and then we are going to have the second person shake the table or the box that it's on. And in this case, we're going to shake it like back and forth in one direction. So we're going to shake it this way. So forward and back this way is kind of our goal. And then we would see how the drawings from our suspended pen change depending on how we shake our seismograph. So here is an example of mine. This light is really reflecting. I don't know if you guys can see. But we can see that we have a wave pattern. So that is when the earthquake is going off and there is rocking happening. We've got some pause here, and then it gets really big. And then we've got the closing out at the end. So this is the kind of thing that scientists would read to determine how strong an earthquake was afterwards. They would have seismographs sitting in different locations, and then when an earthquake started, they would just record while everything was shaking, and then afterwards the scientists could go back and study the waves and learn about the earthquake, including where an earthquake originated from. Because if you have several seismographs, like all around a city or all around a state, the ones that are closer to the origin of the earthquake are going to show larger waves in their report, as opposed to ones that are farther away. So you can kind of close in on where the earthquake started. So I hope that you guys found this a little bit interesting. Obviously, anything that we build is not going to be on the level of scientists, but it does give us an idea of how these things work and how you can make scientific tools pretty simply. And I think that is actually pretty exciting. All right, everyone, I hope that you enjoyed our elementary experiments all about earthquakes. As usual, I will put up some books that you can find at the Manchester City Library that will tell you some more about earthquakes if you are still interested in learning even more about this very cool subject. Again, and if you would like to pick up the craft kit for our craft, we do normally have extras at the children's desk at the Manchester City Library. So if you are in grades 1 through 6, or you want to pick them up for someone who is in grades 1 through 6, please drop by and ask. If you would like to go in person for our next elementary experiments, that is going to be on November 21st. So it's going to be a Tuesday, and we hope to see you at 3:30. Please register on our website, and then we will meet in the Winchell Room to do our activity and craft together, where you will definitely get a craft kit for that. Okay, the very last thing is, if you want to know the theme of the next elementary experiments, it will be at the end of this. As an extra hint, it is something that you might have to do after an earthquake. So see if you can figure out what kind of activities and crafts we'll be doing next time. Until then, bye!